Welcome to this explainer. We're jumping right into something that literally runs our modern world, yet stays completely hidden behind closed doors. You already know the sheer scale of modern data centers. Every app, AI model, and service we rely on lives on heavy iron inside these massive facilities. But here's the catch. As these places expand to the size of shopping malls, the old school ways of monitoring them, they are completely breaking under the weight of all that complexity. So we're going to map out exactly how to go from having chaotic blind spots to achieving total, unified clarity. So let's ask the obvious question. Why does data center monitoring break down at scale? I mean, when you've just got a single server rack, spotting an issue is a breeze, right? But as you scale up into these distributed hybrid ecosystems, your operational complexity just explodes, way faster than your team's ability to see what's actually happening. Suddenly, you're dealing with thousands of interconnected moving parts. You've got spinning disks, cooling systems, layers of complex software, and traditional monitoring simply was not built to look at all of that at once. And that leads us to this pretty wild reality: 3 to 5. Right now, most organizations are juggling 3 to 5 completely isolated monitoring tools. Think about it. The network team is glued to one tool. Storage has their own dashboard. The facilities folks looking at power and cooling, they're on an entirely different screen. Each of these tools is giving you just one fragmented piece of a massive puzzle. It's basically like trying to navigate a huge chaotic city, but your map only shows the highways and completely ignores the traffic lights, the power grid, and the storm rolling in. Now that siloed approach has a massive cost. When something inevitably breaks, let's say a critical app drops offline at 3 a.m., this fragmented system just breeds alert fatigue. Your screens light up with hundreds of red errors across every dashboard, but you have absolutely zero clear root cause. Because there's no correlation between these infrastructure layers, you just end up with endless finger-pointing. Network says it's a storage problem, storage blames network, meanwhile instant resolution completely stalls out, and your efficiency tanks just from the sheer friction of switching between tools to find a shared context that just doesn't exist. Okay, so the crucial pivot here is understanding the difference between traditional monitoring and true data center observability. Basic monitoring just collects metrics. It tells you a threshold got crossed, it tells you something is broken. But true observability, it actually connects those signals. It's the ability to monitor, understand, and, most importantly, correlate data across every single layer of your infrastructure. It gives you the deep context you actually need to pinpoint exactly why an alert is firing so you can fix it right then and there. And this is a total paradigm shift. We're talking about abandoning the chaos of multiple tools, isolated teams, and glaring blind spots. Instead, by bringing in a platform like Sensaka, you get one unified full-stack operational view. Just picture a sleek, dark interface lighting up with crisp, light green signals, showing you exactly what's happening across your entire infrastructure. It's one platform and one shared reality for every single team. Let's zoom in on the 4 layers of infrastructure to see how this works. To understand how full-stack observability maps to the physical and digital realities of your data center, we have to look at the foundational elements. Sensaka gives you incredibly deep visibility into 4 distinct areas all under one umbrella. We're talking about the hardware layer, the network layer, the storage layer, and crucially, the environment layer. Because of this full-stack approach, it doesn't matter if an issue is digital, like a software bottleneck, or highly physical, like a failed AC unit. It's all right there on a single pane of glass. Let's look at the first 2, hardware and network. At the base level, Sensaka's DCOS and IDCOS products track the physical lifeblood of your servers. Using out-of-band access, you're monitoring the actual temperature of the CPU, the RPM of the cooling fans, the health of the power supplies. And simultaneously, on the network side, you aren't just looking at a list of traffic logs, you get a full topology visualization. You can see exactly how switches, routers, and firewalls are interacting, making it super easy to instantly spot traffic anomalies. Right on top of that, you're tracking your storage and environment simultaneously. You're monitoring SAN health, keeping a close eye on capacity and array performance. But here's the real game changer, the environmental layer. We all know servers absolutely hate heat. If you've got a massive AI workload spinning up, those GPUs are generating insane temperatures. Sensaka monitors your UPS systems, your power distribution units, the cooling systems, and, yes, even the humidity. Because let's be real, a sudden spike in humidity can be just as lethal to your uptime as a cyber threat.
Now let's look at cross-layer correlation and connecting the dots.
So how do we actually move from just hoarding data to truly understanding it? Imagine this scenario. Your dashboard suddenly shows a massive latency spike in your storage. In an old-school setup, your storage team is panicking, trying to figure out which drive is dying. But with a unified platform connecting the dots, you might find out the storage itself is totally fine. The system instantly traces the issue back through the layers and reveals that a localized power fluctuation in the environment layer caused a network switch to reset, which congested the network path, which then caused the storage latency. You fix the power issue, and boom, the whole board goes green again. That is the magic of cross-layer correlation.
Moving on to the Sensaka solution, which is built for modern data centers.
By cutting out all that agonizing guesswork, Sensaka really is the natural evolution for IT operations. We aren't just maintaining standalone servers anymore, we're orchestrating massive, complex, multi-vendor environments that absolutely demand a smarter approach. Modern infrastructure is messy. You're managing hybrid setups across on-prem and cloud. You've got highly distributed data centers scattered across regions. And of course, you're running incredibly demanding GPU and AI workloads that push your power and cooling right to the edge. Sensaka is built specifically for this level of complexity, giving you consistent, vendor-agnostic visibility no matter what wild combination of tech you've got running.
Now, let's talk business impact. The operational headaches that constantly plague IT, tool sprawl, endless alert noise, huge blind spots, they get solved directly here. By swapping out multiple fragmented tools for a single platform, you drastically cut your licensing and maintenance costs. You wipe out duplicate alerts through intelligent correlation, which empowers your team to do lightning-fast root cause analysis. You finally get the full picture, actively preventing those tiny, minor issues from snowballing into catastrophic million-dollar outages.
And if you're wondering about scale and reliability, well, over 3 million managed devices globally are being monitored by Sensaka right now. It's already out there across Europe, the USA, and Asia, helping operations teams ditch the reactive chaos and move towards smooth, zero-touch compliance. Which brings us to our final thought for this explainer. If you're ready to get faster control over incidents, seriously reduce your operational overhead, and finally see the entire picture without the blind spots, it really might be time to make a change. You can request an online trial of Sensaka today and experience that unified dark and green dashboard for yourself. But I want to leave you with one final provocative question to think about. In an era driven by AI and totally unprecedented complexity, are you managing your data center, or is your data center managing you? Thanks for joining me on this explainer, and I'll catch you next time.